Good morning, everybody. Today we have a Codeforces Round. This is Codeforces Round 701. Brand new round, brand new day, brand new authors. I haven't seen any of these authors before. Keyrem, Mr. Brianix, Mr. KOOL, The Scarce, and Talent. Probably mispronounced a lot of those names, but oh well. Here we go. Brand new round. It's Div 2, although Div 2 rounds recently have been somewhat difficult, to be honest. It's like LGMs have struggled to solve set, which in my opinion is what a good Div 1 difficulty should be. But, oh well, there you go. I'm also super prepared today. Look at me, I've got a title and everything. We're going to be doing all of our work on the computer, so we'll walk through my thought process there. We've got our CF notifications ready. CF notifications, for those of you who aren't familiar, is this website that I built where you can type in your Codeforces handle and then it'll give you a sound when you solve a problem. So it's kind of useful. Here we go, Codeforces Round 701. We've got our template ready as well. I also added comments to my template in 15 minutes that the round was delayed, so that if you're not familiar with it, you can read stuff about it here. All right, here we go. Problem A. Add and divide. You have two positive integers a and b. You can perform two possible operations. A divided by equals b, or b plus plus. Find the minimum number of operations required to make a equal to 0. Well, the number of times you'll add is not very many. Yeah. So, okay. Multi-test case? I think so. A equals this, B equals this. A divided by equals B, and then C plus plus. Okay, so keep doing that. Int best equals integer dot next value. Yeah. Okay, then for int times equals 0 times less than 30 maybe, times plus. I don't know exactly how many times, but it won't be that many. Then best equals math.min of best, and times plus count a comma b plus times, and return best, or no, sys out best. Come on, Eclipse, you can do it. 4, 9, 2, 12, 3, 1. Let's submit problem A, and on to problem B. Replace and keep sorted. Pretest pass, that was quick. Given a positive integer k, two arrays are k-similar if they are both strictly increasing. They have the same length. How's this going? We're good. They have the same length. All their elements are positive between 1 and k. They differ in exactly one position. Gotcha. You're given an integer k, a strictly increasing array a, and q queries. For each query, you are given two integers l and r. Your task is to find how many arrays b exist, such that b is k-similar to this array. Let's do this example by hand. So we've got 1, 2, 4, 5. Problem B. and then they say the range 2, 3. So here's this range. So how many arrays are there in this range that work? So if it's this element, we can change it to 1. They differ in exactly 1 or 3. If it's this element, it would be 3 ... all the way up to k. They have to be strictly increasing? Yeah. So, okay, let's say you have some numbers. Wait. Oh, we're given k. K is equal to 5. So we have 1, 2, 3, 4, and 5. So 2 is taken. 4 is also taken. Let's use a different color. This can be in 2 different ranges. This can be in 1 range. This can be in 1 range. So the only interesting part, you're going to have a prefix of 1s, a 0 for every element in the array, a suffix of 1s, and then a bunch of 2s in the middle. And that's the solution, I think. We're guaranteed this is strictly increasing, and we're also guaranteed everything is less than k. Yeah, okay. I think we're fine then. Wait. Oh, this looks like a negative sign. That's very confusing. I would not have chosen that symbol, but that's fine. I understand what they mean. Okay. Good morning indeed. Alright, so single test case, int n equals this, int n queries equals this. Do we have lots of queries? We do, so we're going to need print writer. And then we also have k. We have our array. And we need to answer queries. So we have the left and right index of this range that is of interest. Then what we want to do is, count the total number of things. So int n zeros. So the number of things that are 0 will be r minus l plus 1. Int n ones will be the number before the first element, so a at l minus 1, plus the number after the last element, so k minus ar. And then n2s will be everything that isn't a 0 or a 1, so k minus n0s minus n1s. So then the ants will be n1s plus n2s times 2. Let's see if this works, and then we'll submit if it does. 4, 3, 8, 9, 7, 6, 9. Looks good. We'll listen for Codeforces notifications then. A pair of positive integers, a and b, is called special. Awesome. If a divided by b equals a mod b. Cool. This is the result of integer division. This is its remainder. Given two integers x and y, find the number of special pairs a, b. Oh no, I don't like these types of problems. This is math. Find the number of special pairs such that a is less than x, b is less than y. Disgusting. I think it's going to be an n root n thing. That's what it feels like. Oops. Okay. Can we just have lots of solves? Is this that easy? Yeah, no, I feel like Mr. Decomposition has the right idea. I don't want to do problem C, it's ugly. Maybe later we'll do it. You're given a matrix consisting of positive integers, n rows and m columns. Construct a matrix B of positive integers. It should have the same size as A, and the following conditions should be met. Each element should be up to 1,000,000. Each element should be a multiple of the thing in A. The absolute value of the difference between numbers in adjacent pairs of cells is equal to k to the fourth for some integer k. Excuse me. Wow. Interesting. Only up to 16. Thank you for not guaranteeing it. This is the right way of saying it. I very much appreciate that. Good job. What is the GCD of all numbers up to 16? Because if it's less than 10 to the 6th, that's golden. Or so what I'm doing here is, yeah, just finding the LCM of all the numbers between 1 and 16. I res equals res dot multiply O dot divide res dot GCD with O. That's funny. That is so funny. set height and width, int h equals this, equals this, int y equals 0, y less than h, y plus plus, int 0, s less than width, x plus plus, this out, 720, 720. You know what this is? Pretty sure this is a highly composite number, if I remember correctly. What a troll problem. I love it. Great problem. Best problem I've seen in a long time. Seemed really hard at first, but I'm like, oh my goodness, so fun. Oh, I feel so happy. Oh, did it? Why did it get wrong answered? I see. Okay, well, looks like we need to read the input, but not to worry. X plus y divided 2 is equal to 0. Otherwise, this out 720 plus rut-row, how big is 16 to the 4th? 16 to the 4. I think we're fine. Plus x times x. Okay. Oh, this should be, call it s or something. Let's try this on samples. I think it's right. But it's faster to just submit than actually see. All right. Yeah, so good enough. Nice. I'm in first place. First place. Okay, awesome. That's fun. Nice. I don't know if I've ever been in first place before. So cool. I love being in first place. Oh, that's amazing. Oh, Anton's beating me. Well, it was fun while it lasted, huh? You're given an array of integers, and an array of integers is a hybrid. Oh, I guess I should just solve problem C. I'm having so much fun. I'm going to read this first. It's a hybrid if for each I, at least one of these conditions is true. B of I is equal to A, or B of I is equal to the sum of all the integers before it. Find the number of hybrids of this array. Is it not just like 2 to the n? Oh, they can be negative. Three. So this one can be, why is 1 negative 1? Okay, let's try and understand this problem first. Why is 1 minus 1 2, not an answer. Oh. Never mind. I'm thinking about it backwards. You're given the array that's either the prefix sum or the original. You're not given the original. So that means yours is either so what they give you interesting. I guess, yeah, let's read F. Given an, okay, so let's do this example. So 1 minus 1, 1. So that was B. This problem is F. So I see. So the prefix sum array would be, well, either way this has to be 1, right? Yeah, that's forced to be a 1. Now if the prefix sum is minus 1, that would make this minus 2 for the prefix sum. We could also have the prefix sum be or we could also have this just be the value, so then it would be minus 1. Okay. Then for this value, if it's the prefix sum, if we want the prefix sum of these things to be equal to 1, that would make this be 2. So 1 minus 2, positive 2. Okay, we could also have 1 minus 2 and then 1. For this, we can have 1 minus 1 could be the value or the prefix sum. Gotcha, because the prefix sum of this is 0. Yeah, okay, I think I understand. These numbers can get quite big. So we need to say like, all that matters is the prefix sum of everything before it. So one interesting thing we could do is like number of ways to hit each prefix sum. With the number of ways of getting a prefix sum of each number, then we need to so you can get this. Yeah, you can either have prefix sum times 2, or no, that's not true. You can have prefix sum plus b, plus bi or bi can be your prefix sum. Yeah, so it seems like we can maintain that using some delta with a hash map. Yeah. Okay. Should we go do that? Probably. It's probably the play. This is problem F. Array A equals, this is an array, right? I've kind of forgotten. Yeah. Dot read array of size n. Okay, so then we should probably have a hash map. This is the number of ways to hit each result. It's the mod, okay. Yes. So what do we need to maintain? So long total ways equals 0. Long delta 0. Total ways is equal to 1, really, because you can have a sum of 0. And ways dot put 0 sum of 1. Okay, so let's read each value. Okay, so we want to see the number of ways that the prefix sum if everything before us is equal to 0. Yeah. So we want, let's just have these two methods. So we have like public void get well, I guess we'll just have to do it by hand. Yeah, let's think about this for just a minute or two more to make sure we actually have the solution. So you can either place the previous prefix sum plus this thing. You would do this if ai is equal to bi, or the prefix sum is equal to bi if bi equals like the sum of ai before it, or of aj, or I guess j is less than I. Okay, good. So the number of ways plus equals like everything where the prefix sum is not equal to 0 for each step. Hope I don't run into time limit issues here. I don't think I need to divide. I don't think I need to multiply either, to be honest, but oh well. So, and then at the end, sys out total ways. We need a print writer. Do we need a print writer? Into the 4, no, we're probably fine. Okay. So what do we do here? Long n zeros will be equal to n ways dot get. Delta is what you add to everything, so minus delta. Yep. Okay. This is get or default. By default, get 0. 0L. Good. Now we have this many zeros. So to add will be total ways minus n zeros. Okay. Delta plus equals I, because this is what's going to be next. If we place this. Otherwise, n ways dot put negative, or what is this? It's going to be the prefix sum will be I minus delta. And thing will be to add plus n ways dot get or default. What do we need here? So this is going to be I minus delta. The default value is 0. Yikes, okay. Is that it? No. Let's do an example. So suppose your array is 0 minus 1. Or is, I guess, 1 minus 1. After the first thing has to be 1. So there's one way of getting 1, 0 ways of getting 0. When you get minus 1, oh, total ways plus equals to add. Let's see. Okay. So I is -1. Oh, are we sure? Yep, we're sure. One test case. Three. Wait, the 3 is the right answer. Oh, we are right. Okay. Good. So this is the entire code. This just needs to all be using this mod. Sub I and delta. Good. Yeah, I think that's right. 328. Wait, was I wrong before? Darn it. Oh, I was. Okay, that's fun. How did I boost translate this? Is it really that difficult? Oh. Yeah, I guess we don't want the delta to be under mod. This shouldn't be a thing. That's asking for trouble. Okay. And then this should be I minus delta. Yes, we have to be a little bit more careful here. We just need the number of ways under mod. Do we think that actually broke it? Because that would be funny. That's a good test case. They did. Wow, they are so generous. That's insanely generous of them. 3, 8, yeah, okay. You can try it. I've fallen quickly. Now I'm back in 3rd place. Man, my scoreboard, oh my goodness. So patchy. What do we do next? Do we solve problem C? Or problem E? I don't like math though. Okay, I guess problem C is next. So we'll try problem C. A pair of positive integers A and B is called special if A floor B is A. Yeah, okay, find the number of special pairs. A is less than X, B is less than Y. Let's read the other problem. I don't want to do math. I'm just not in the mood right now. Given n-1 integers and a tree with n vertices rooted at vertex 1, the leaves are all the same distance. d from the root. Recall that a tree is a connected, undirected graph without cycles. Distance between two vertices, the number of edges and the path between them, all non-root vertices with degree 1 are leaves. Oh, so the root is not a leaf, okay. Is n at least 2, good. If vertices S and F are connected by an edge, the distance, and the distance from F, distance of F from the root is greater than the distance of S from the root, then F is a child of S. Initially, there is a red coin and a blue coin at vertex 1. Let R be the vertex where the red coin is, and B be the vertex where the blue coin is. You should make D moves. A move consists of 3 steps. Move the red coin to any child. Move the blue coin to any vertex, such that the distance from 1 to B prime is equal to the distance from 1 to B plus 1. So red moves to a child. The blue coin can move to anything of the correct depth, of the same depth as R. Note that B and B prime are not necessarily connected. You can optionally swap the coins if you want. Note that R and B can be equal at any time. After each move, you gain the absolute value of the difference. The maximum number of points you can gain after D moves. Yeah, okay, so for this problem, I think we can do it by yeah, okay, so a bottom-up approach makes the most sense. If we arrange the nodes in order of a pre-order, post-order traversal, particularly their pre-order, if we do an Euler tour through the tree, maybe I should draw this out. Okay, so that's F. Let's now work on problem E. So let's say we have some tree. What happens? How many moves do you make? You should make D moves. Can you make most D moves or exactly D moves? This is very nice that they made this whole animation for us. Oh, you get the absolute value of the difference between these. I see. So the number of points you get here is tricky. It's some constant plus your value minus something, or some constant plus something minus your value. Oh, I guess the other thing would be very easy to find out then, if that's the case. Yeah, so we'll get this problem eventually. Let's look at C, unfortunately. Or should we just do this now? Yeah, okay. Well, it looks like our goal here is to solve set. And it looks like, well, it's certainly possible. So we're going to try that. How are my friends doing? Not bad. Yeah, okay, I guess we'll go after C, maybe. So a pair of integers is special if A over B forward equals A mod B. Okay. So let's just think about this for a minute. What are some special pairs? So it's like, maybe A is the interesting thing. So let's say we have 1. Or maybe what they're equal to is interesting. If it's equal to 1, then B can be 2, or 3, or 4, or 5. So if it's 2, then A would be 3. It's 3, A would be 4, 5, 6. So the number of things there are is one of these will get cut off first. Okay, what if it's equal to 2? Then the options are, let's say, well, it could be 1. Let's give ourselves some more room here, because we have missed some cases. It could be 1 or it could be 0. So this is the division. This is the mod. This is the, I guess it's value A. So let's say it's equal to 1. Then A would be 1. Wait a second. So this is, they're both equal to 1. The value under mod is equal to 1. The division is equal to 1. So then this would be, this is B. This isn't the division, this is B. And this is what A is. B is 1. That means A needs to be 2. No, it's not possible. It's got to be greater than 1. So B is 2 is the smallest we can get. Well, you can't, it doesn't work if it's equal to 1. Okay, so try again. Let's say it's equal to 2. So what does B equal for each of those things? What does A equal? B has to be bigger than 2. If the, yeah, okay, so let's say B is equal to 3, or 4, or 5, or 6. If B is 3, A needs to be 2 times 3 plus 2. which is 6 plus 2, so that's 8. Otherwise, this needs to be 2 times 4 plus 2, which is 10. 2 times 5 plus 2, 10 plus 2 is 12, 14. Yeah, okay, so the division and the mod, well, they can both be equal to 1. Yeah, no, this is fine. These are legal. These are all okay. The division and the mod can both be equal to 1. So here we count up by 1s. Here we count up by 2s. So it's 10 to the 5th and 10 to the 5th. Yeah, this value here is at most root n. Right, because this has to be bigger than this. 3 has to be bigger than the 2. It's 3 times 2 plus whatever. So we brute force this. The number of things you can do with math. Okay, so not actually that bad. Still annoying math, but not bad. So long x equals this, y equals this. What are these x and y? This is the max a. This is max b. Equals 1, equals less than, equals plus plus. How many test cases? 100. Good. I think. Should probably be good. Let's make this a long, because I don't want to worry about overflow. Yeah, fine. Okay, so, long ways equals 0. It's out 2 ways. So then, what do we need to do here? We need to find how much room to play with we have. So int min b is equal to equals plus 1. Int max, this is a long max b would be maximum smaller number. Well, yeah, okay, so then do we need to binary search for this? Is this, am I doing this right? 3 times 2 plus 2. 4 times 2 plus 2. Oh yeah, there's always a plus 2. So there's a plus 2, and this is 2 times each of these. Okay, so long times b fits will be max b long times a fits will be okay, so this 2 is equals plus equals times, so it's just 1 plus equals times okay, so a value is equal to equals times 1 plus n times, or like, yeah, which item it is. So that means max n times equals a value minus equals over equals continue, I think. Otherwise, it'd be pretty cool if this worked, wouldn't it? 1 0 2 3 5 1 4 1. Oh my goodness, it's right. Oh. Okay, not bad, not bad. Let's get E. So we've got our tree with some stuff. We need to do some more stuff on it. This is a much easier Div 2 round, by the way, just saying. It's very, very approachable compared to the previous ones. We have a tree and -1 integers. All the leaves. Oh, I didn't read this. That's so convenient. Very nice. All the leaves are the same distance d from the root. Yeah, okay, so let's go back to the drawing board. Did I start working on D yet? I haven't. Give me 100%. So the idea here is we have some tree. I swear I've drawn this tree up before, but maybe not. So we have a bunch of choices. Each one has like some value or like some label, I guess, and then some value. If we're choosing this, yeah, okay, so what we would do is for each of these, we would say, where else would it be? In the entire array? Entire array indeed. So where in the entire array would it be, other than ourself? We want the thing with the biggest, we want like value plus label or value minus label. We need to keep track of these two things. That's what we would match with ourselves, gives us a new value, then we assign that to the parent. Yeah. I think this is actually a very easy set. Let's finish it out. Or is that a long? I guess it's a long value to label. Node to label. Okay. Do we need to do a DFS or should it be a BFS? Alright, DFS would be nice. Hopefully it doesn't. Yeah. Remove our parent from the DFS. We should also store the depth. This dot depth equals depth. For each of our kids, and in .dfs, this is the parent, depth plus 1 is the depth. Good. Is this multi-test case? Yep. Okay. We have a bunch of nodes. Each of these have a bunch of values. Oh. I guess they just give us the parent. So we don't need this DFS at all. Or I guess the DFS is fine. Oh, they don't even tell us D. Well, I guess that's fine. Yeah, that's fine. Cool. So we don't have to remove it. We don't really care about the parent even. It's just to set these values. N equals this, node array nodes. So then we'll set each node's label. Then we want to do DFS. Is the root node 0. Yeah. Nodes 0.0.dfs depth 0. Okay, how many test cases? So we don't need that, but we should probably do stack trick. Maybe. All right, so then we'll store the nodes at each depth. So then we should probably, yeah, okay. So this.value equals math.max value for parent. Then we need a comparator. Or we don't do this. We want to do this some other time. Okay. Yeah, good. All right, so now for each node at each depth, n-1, depth is greater than or equal to 0, depth plus plus, or minus minus rather. If depth is equal to 0, nodes, or I guess just return. So we want just greater than 0. And then we want nodes at 0 dot get value. This out nodes at 0 dot value. Good. Okay. So if nodes at a depth dot is empty, then continue. Otherwise, assume it's not empty. If it's just a chain, we get 0 points. So if nodes at a depth dot size equal to 1, 6 out of 0, continue outer. Okay. It's not just a chain. Array list node sorted forwards, or sorted 1 array list or equals nodes at a depth dot clone sorted 2 equals nodes at depth dot clone. Okay, collections dot sort sorted 1 by a b give us one dot compare a dot value plus a dot label to b dot value plus b dot label. Also, first we want for node nn in nodes at this depth, and then dot get value. Okay. Then sort array 2 with value minus label. Node array to check equals something. So this will be sorted 1 dot get. Well, okay, let's just make these backwards. Clean up our code. Okay, for node other and check with, we need to compare them. So if, okay, then for node first in nodes at this depth, if first is equal to the other, then continue. Otherwise, if they're not equal, we can pick both of them. So first dot value equals max dot max first dot value, or first, oh, this is value for parent. First dot value for parent is the max of the value for parent, or first dot value plus last dot value, or plus other dot value plus math dot abs first dot label minus other dot label. We take the value for parent of nn. I think that's it. I think we're good. Let's try it. Nope, not quite. Because I'm not reading in the edges. Yeah, okay, so we read in the nodes, then zero. Nodes it pair dot adjacent dot add nodes at I. Is this depth? Is this DFS just to set the depth? Then we don't even need it. Nodes at I dot depth equals nodes at pair dot depth plus 1. Is that a problem? One, two, three, four, five. 1, 2, 3, 4, 5. Oh, are these the values? Is it parent first and then the value? Yeah, okay. Fine. Not 0. Yeah, okay, what's wrong with this? Value is 36. Stat value for parents. Oh wait, no, that should be the step value. So this should be I guess, or I plus 1 maybe even, would be nice. What about at depth 1? This is not true. Okay, so this is just, you have to handle this and be annoying. Yeah, okay. So, array list node check with array list. So what if they're the same? They go to the same node. So then first value for parent equals math.max first value for parent, or first value. That's it. This is 45, you say? This gives you 36 points alone. Okay, so it is going to be pretty big. They need to be in different subtrees for us to get this bonus. Yeah, okay. I see. Yeah. We only get, all right, so here's the problem. So the issue here is that we only get this value for both of them. No, we always get the value for both of them. Wait, do we get the value for both or the value for one of them? Oh, yeah, we leave. Yeah, okay, I see. So we get math.max of one of these, first.value or other.value. Plus the label. Yeah, okay, so that's the issue, but that breaks the sort. So we need, what, 2 more? I think. So this is sorted 4. We also need a sorted 3. So these need to be, these assume we don't use the value, we just use the label. Okay. I think this should be fine. Real question is runtime. So 14, 45, we're wrong, we're too small. Too small, interesting. 35 minutes left. We need to solve this set. What's going on here? So the idea behind the solution, let's verify this, is we have something. We say if A is in this subtree, if we leave our A here, if one of the kids we pick has to be in this subtree, then we do that. So one of the kids has to be in this subtree, and then they take something else. So then for our parent, we get one of these things here. And okay, so we have to use our label at least in the calculation. But you could use someone else's value. Yeah, suppose this wasn't here. So you could use our label. Use this label. You use his value. Is it the max of the values or both of the values? We don't get overlap is the problem. So if they're disjoint, no, you only get one, A only goes to one subtree. So you only get one of the values. So this should be the max of the values. So we either keep the value for parent, or we use our value if we keep A, or if the other person keeps A, the absolute value of the labels. Okay, that's good to know. The problem is not with me selecting too few things. Should we just draw out a case? Probably. Okay, let's draw out the last case, I guess. It's kind of annoying. So we have, wait, what? I thought the parent was less than you. Nope. Okay, just kidding. That's the problem. Gotcha. All right, so this doesn't work. 23. Okay, that seems right. Lots of false positives possibly, but yeah. Okay, so get rid of this. Let's submit without stack trick because, I don't know, we're not going to win this contest anyway. We took way too long on that problem. And if we run time error, we can do stack trick. TLE is what I'm really afraid of, even though it's linear. There's lots of stuff. Okay, we got it. How'd we do? 16th place. Not bad. Not bad. Yeah. Anton beat us. Nice job to him. Nice job to him. Nice job to Neil. Yeah. Who's doing the stream today? Is there a stream? Yeah, Neil's doing a stream. But anyway, we'll do solutions here. Maybe beat him to it. Sounds good. All right, 28 minutes left. How are my friends doing? Here's my coach. Not bad. Ruben, love to see it. +4. Let's go, man. You can do it. Rainboy, having a great day. Let it rain. Let it pour. He's going to be in Div 1 soon with this kind of performance. To be fair, F was a pretty easy problem. I really wonder how good Rainboy would be if he took contests seriously. Because he solves some very difficult problems. So he's probably quite talented. But it's interesting. Yeah, anyway. Let's do solutions. What do you say? Okay. I say we do them. And I'm the one making the video, so we're doing them. All right, problem A, add and divide. So for this problem, the idea behind the problem is that you can do one of two things. You can either increment the number you're dividing by, or you can divide and floor whatever this number A is. Those are the two things you can do. The thing to notice here is that, let's say you increase the number you divide by to like 30, right? Let's say it's already at like 30 or like 20 or something. If you want to increase it more to a number like 40, that's going to take 20 moves. Instead of taking 20 moves, you could just divide by 20 times, right? So there's no reason for you to increase it to something like by more than like 20. Because once you've increased the number you're dividing by to like 20 or whatever it is, then increasing it again will it's not going to be that helpful. So it's better to just divide a bunch of times than it is to increase a bunch of times after a certain threshold. Now it's possible that increasing it from like 2 to 3 might be helpful. I'm not really sure, to be honest. It seems like that would be the case. It seems like there are situations where A is really, really big, where you might want to increase B by 1 or 2, or maybe 3 or something. But you don't want to increase it by more than like 20. And as long as B is bigger than 1, it's going to take log base B of A steps, which is like, in other words, at most 30 steps, maybe, most like 35 steps. So your runtime will be very fast. So basically, what I'm saying here is, what you can do is brute force how many times you increment B first. Obviously, you're going to increment, then you're going to divide. You're not going to divide and then increment. But you're going to brute force how many times you need to increment B. Once you know how many times you're going to increment B, you increment B by that much in the beginning, and then you just repeatedly divide by B until you get to 0, until A gets to 0. The number of times you need to increment B is at most 30. It'll take at most 30 steps as long as you special case when B is equal to 1. So your runtime is going to be order 900 per test case, order 30 squared. Here's the code for that. So, yep, I read in A and B. I brute force the number of times I increment B. The total number of steps it takes is the number of times I increment B plus the number of steps it takes to get A to 0, which I do here just with a while loop. Hopefully that makes sense. You can pause the video if you want to look at the code. Let's move on to problem B. Replace and keep sorted. So for this problem, you have this kind of complicated definition, but basically you have some array. You want to make some other array where exactly one element differs. And it has to differ. It can't be the same, right? You can't have two matching arrays. So you need exactly one element to differ, and you want the array to still be sorted in strictly increasing order with no ties. So let's look at this example. The first example they give is very good. I think I have it over here actually, so we can just reuse this. Good. So here's the array they give us, 1, 2, 4, 5. And you're going to have a bunch of queries. Each query is like some continuous range. And it's like, instead of looking at the entire array, they want you to just look at the part of the array that they give you. So they might say just look at this part of the array. They might say look at the entire array, something like that. Basically, all this is doing is it's forcing you to find a solution faster than in linear time. They want you to come up with an order 1 solution or some sort of order log n solution, something like that. So let's say they give you this part of the array. Now you can replace each number with a number between 1 all the way up to 5, where 5 is equal to k. This is the number that they give you for k. And this first 2, it can't be a 2 because let's say we're going to brute force the number we change. So if we change the 2, we have to change it to a 1, a 3, a 4, or a 5. But we can't actually change it to a 4 or a 5 because then it won't be smaller than this 4. So this can be a 1 or it can be a 3. The 4 can be a 3 or a 5, and that's it, right? So our choices are change the 2 to a 1, change the 2 to a 3, change the 3 to a 4, or change the 3 to a 5. Let's look at all of the numbers between 1 and 5 and see how many ways there are for us to change each of them to it. So the numbers between 1 and 5 are 1, 2, 3, 4, and 5. There's one way we can change something to a 1. There are no ways we can change something to a 2. Because we already have a 2 in the array, nothing else can be equal to the 2. And if the 2 doesn't change and we're trying to change the 2, then the array winds up being the same. So nothing can be a 2, also nothing can be a 4. There's one thing that can be a 5, which is we could change the 4 to a 5. But there are 2 things that could be a 3. And in general, if there's any number that's like between 2 other numbers, right? So maybe we have like a 1 here and like a 7 here. Anything between these, you can have it can either be set from the 1 or set from the 7. So what this array is going to look like when we're done with it is like the number of ways to reach each number. The number of ways to reach the thing smaller than the first number in the array is just going to be 1. So we're going to have a bunch of 1s in the array in the beginning. And also the number of ways to reach something bigger than the biggest element is also going to be 1. So we're going to have a bunch of 1s at the end. We'll have a 0 here, a 0 here. We'll have a bunch of 0s in the middle too. Any element that we had in the original array, we'll have a 0 for. We know all of those elements are distinct. So just the number of different elements in the original array is going to be the number of 0s we have. And then the rest of these are going to be 2s. So if we know how many 0s, 1s, and 2s we have, we can figure out what the sum of all of the elements in this array are. Just to repeat, the number of 1s is equal to the number of things smaller than the first element in our range. The number of 1s in the end is the number of 1s bigger than the last element in the range. And the number of 0s is the number of things in the range. The number of 2s are the number of things that aren't 0s or 1s. So in particular, here's what that looks like. We have the number of 0s, which are just the number of things in this range. The number of 1s are the number of things smaller than the first element they give us and bigger than the last element. And the number of 2s are everything else. Our final answer is the number of 1s times 1 plus the number of 2s times 2 plus the number of 0s times 0, but that's not going to change the sum. And then we just print that out. And that's how you solve it. It's that easy. All right, problem C I thought was actually pretty difficult. I struggled with it for a bit. It was the second last problem I solved. but here's the idea. What the problem is, first of all, is you want to count the number of pairs where a divided by b is equal to a mod b. So what we're going to do is, instead of thinking about that, we're actually going to consider what these two things are equal to, right? They're equal to the same thing. Let's think about what they're equal to. So, yeah, here, wait, where is this? C is over here. So let's say that they're both equal to 1. If that's the case, b can be a bunch of things. It could be 2, 3, 4, 5, 6, whatever. But you know that a, if we know what a mod b is equal to and a divided by b is equal to, then a is equal to 1 times b plus 1. Right? So if this is 2, then 2 times 1 plus 1 is 3. 3 times 1 plus 1 is 4. 4 times 1 plus 1 is 5, etc. So we have, for each b, we can figure out what the a's are. We can also figure out how many things there are where this is the case. In particular, we know b has some maximum value that it can be. A also has some maximum value it can be. We can figure out when each of those numbers will hit their maximum value, and we can count how many valid b's there are, how many valid a's there are, whichever range runs out first is our limiting factor. So yeah, that's the idea. The idea for runtime is we can brute force this number because the smallest value of a is the value for b times what this value is. Let's call this like x, is b times x. That's the smallest value a can be. We also know b is greater than x. So the value, and the reason for that is because something modulo b is equal to x, which means b has to be less than x by how modulo works, right? If you take like n modulo 7, if that's equal to 4, this 4 has to be smaller than 7, right? N mod 7 can't equal 10, because if n mod 7 was 10, well then n mod 7 would really be 3, right? Because 10 isn't less than 7. So we know x has to be less than b because of how mod works, and that's one of the constraints of the problem. Like a modulo b has to be equal to x, which means x has to be smaller than b. So that means the smallest a can be is b times x plus x, I guess, which is bigger than b times x. So when x is bigger than the square root, if this is bigger than square root of n, then nothing will happen. So our runtime is going to be the number of test cases times square root of n. Sorry, there's a lot of stuff going on there's a lot of stuff going on this screen. Yeah. But what you can do is brute force what this value is, brute force x, and then count how many occurrences there are. I won't worry about the math too much because it's messy and I'm not good at explaining it. It just takes some work on paper, but here's what it looks like. So the a value is equal to, this is x n times, or sorry, equals is x. I guess we can replace this with x. So a mod b is going to be equal to x. A divided by b is also going to be equal to x. So the number of times a fits will be this. And if this is less than x, that means there aren't any b's that work. Otherwise, the number of b's that work is times the number of b's minus x. That's how many there are on the upper end of that range. We know how many a's there are, so the minimum of these minus x will be the number of times we can have this x as both the mod and the divisor. And then we print the answer. You can probably do something a little bit smarter. My runtime is actually 10 to the 5th times t, but that's fine because this is order 1. Okay, very good. That's problem C. On to problem D. Multiples and power differences. Yeah, so this problem is kind of wacky. Please notice this, right? This is the spoiler alert of the problem. All the values in the array are at most 16, right? So they're all pretty small. So the other cool thing to notice is that, where's my problem D? Okay, I don't know. I'll just write it here. Turns out that the LCM of all of the numbers, the lowest common multiple of 1, 2, 3, all the way up to 16. This is equal to 720, 720, which is a highly composite number, or antiprime, if you prefer. So, yeah, what that means is, if we fill our array with all of these numbers, then no matter what they give us as input, this will be a valid output, right? Just some grid of this. Because if we do that, we'll always have a multiple of that number, right? And all of the adjacent differences will be 0. So if we have some grid that looks like this, we can just fill it all with this number. Now, that doesn't actually work. The reason it doesn't work is because you can't have two numbers that are the same, that are adjacent. So what we can actually do is just two-color it. So we can say, for all of these squares that I'm circling in red, we'll make it this number plus, let's say this is x, right? This number plus, or let's say the value in the space initially was x. We'll have it this number plus x to the 4th. So the difference between any of these adjacent things here will be this thing to the 4th. So some positive number to the 4th, which will be like some positive difference. So we'll always have this positive x to the 4th difference that we want. We also know none of these will conflict with each other, because all of these squares that I haven't circled, these are just going to be 720, 720, right? So yeah, so it's very easy. So all of the differences will be the difference between some red square and some uncircled square, and they'll just be, for the red square, whatever its value is to the 4th, that's what the difference will be. So this is a constructive problem, and I saw it right away. So if you see it right away, it's super easy. If you don't, it might be tricky. But yeah, I guess you should probably get a hint about the fact that it was easy, that someone solved it super early in contest. So that tells you there's some easy solution. So look for like easier stuff before harder stuff. Yeah, and don't be afraid to submit wrong answers before reading the problem, because they don't penalize you for it. Cool. After I solved this problem, I was in first place, by the way. So cool. Anyway. Move and swap. You have n-1 integers with some tree. Oh yeah, this one. Okay, so for this problem, you've got a red coin and a blue coin. They both start at the root of some tree. After a given turn, or after on a turn, you move the red child down to, or the red coin to some child of the node it's currently on. You can move the blue coin to any node on the same layer. So in this example, you move the red coin down to its child. You move the blue coin to any node on the same layer as the red node. And then the number of points you get is equal to the absolute value in the differences of the labels of the two nodes. That's a bit confusing. You might want to read the problem because it's a little difficult to explain. But yeah, in this case, right here, they're at these two nodes in the middle here. So the values are 6 and 9, which gives them 3 points. At the end, the values are, or the labels are 9 and 3. That gives them 6 points, because the difference between those is 6. You want to maximize your total score. Oh, also, after you move the red and blue down, you can switch them. You can swap red and blue. Yeah, so you want to maximize your total score. How do you do that? So the idea behind the problem is that absolute value can happen in two ways. So either it's left minus right or right minus left, whichever is bigger. So we'll just consider both of those. The first thing we're going to do is split it up by layers. And then for some node, we say if one of our, so the red token is special, right? Because it has to go to its kid, but the blue token can bounce around wherever. So the blue token is a bit easier to think about. So we're going to handle the red token. And then we're going to say, if you had the red token, what is the most total points you could get if any of your kids, from you having the red token on, what's the biggest total sum you can get? And and that's what we're going to keep track of. When we have that, if we have that answer for the root node, that'll just be the final answer. So that's what we want to get. Yeah, let's look at some example here. So if we have this tree, if the red token is here, the blue token is going to be in one of these positions, right? Maybe here or maybe here. We want to pick some blue token optimally. So what we want is we want the following to be true. So we want, like, the number of points we get is the max of, we can keep the red token here. So this is going to be like, let's give these labels. We'll say this is node 1, node 2, node 3. So the number of points we get is equal to the max of the red, like, DP value, where this is, if we keep the red token here, like in this subtree, how many points do we get? Or the blue DP value, which is, if we were to swap, the red token would go to the blue further DP value, and then we would keep the blue token, but the blue token can move anywhere, so which tree the blue's in doesn't matter, plus the absolute value of the red DP, or red label, minus the blue label. So there are two things to notice here. This can either be, because of how absolute value works, this is either going to be red label minus blue label, or it's going to be blue label minus red label. So if we look at this from the perspective of the blue node, there are only a couple nodes that might be the best blue node, right? Either we're going to use the blue's DP value for the blue subtree, either we're going to swap, in which case we want to use the blue's subtree value, or we're going to keep the red node, or we're going to keep the red node in the red subtree, and it's going to go to one of the kids. In that case, we don't care about the blue subtree value. So either we're going to add the blue subtree value or we're not, right? So either it's important or it's not. If it's not, we can just ignore the subtree value. If it is, we're going to add that to the total. So we should increase that, like we should use that as part of our sort when we sort the blue nodes. So we're just going to do it twice, once when we add it, once when we don't. Now after that, we have this absolute value thing, which is tricky, because for some node, it's kind of tricky what the best absolute value is. It might be the biggest one, it might be the smallest one, it might be somewhere in the middle if it has a really good DP value we want to use. But basically, the amount blue contributes is always either, you're always either going to have, like, let's say we're using this blue DP value, right? The sum is always either going to be red label minus blue label plus blue DP or if we're going to use the blue label, the only other option is is blue label minus red label. Plus this DP value, plus blue DP. So as far as blue's concerned, we want to pick the best one of these. Either we want to pick the best blue label plus blue DP, or the best blue label, either we want to pick the best negative blue label plus DP, or the best positive blue label plus DP. So either blue DP plus blue label, or blue DP minus blue label. Those are these two choices. Yeah, so there's only one node that's best for that. Now, we have to special case that because that node might be the same node that we're considering taking now. So we might need both the best node and the second best node because we want the best one that isn't ourselves. But either way, there are only 4 possible best nodes we can consider. If we need 2 for each of those, there are 8 possible best nodes to consider. And we'll just try all of them for each node. So that's the solution idea. So, okay, code looks like, code for D. Here's the code for D. It's that easy. Boom. Code for E is a little bit more messy, but here's what it looks like. Make each of my nodes, set each of the nodes parents, do a DFS, set each of the nodes labels. Okay, so this is a big block of code because there's lots of copy and pasting here. But I have 4 copies of all of the nodes at this depth. I sort them by a few things. Let's look over here. So I sort them by value plus label, value minus label, where value is like, if this is the red node, what do we keep below it? Label, if we don't use the value of this blue node, or negative label, if we don't use the value of the blue node, and this is the smaller of the two. So then I have this array list of nodes I want to check with, and it has between 4 and 8 nodes in it. So it's just the best of each of these array lists and the second best of each of these array lists. And then for every node I want to check with, I say, okay, if these are the same, then I guess you don't even need this line. Yeah, you don't need this. Okay. So you keep the red node in one of the subtrees, and then for the label points, you get the absolute value of the difference, and that's it. And then at the end, the answer is the 0th node's value. I call this get value because it just sets my value to the max of the values for parents for each of the kids. So yeah, I guess I didn't totally cover all of my code details, but it would take a long time if I did, so I won't worry about that. Okay, last problem. Problem F, copy or prefix sum. So yeah, so this problem is actually pretty easy. It's a bit difficult to wrap your head around, but once you do that, it's not too bad. The idea is you have some array, and this is the array B. So each of the elements in your array is either equal to the prefix sum of the first several elements in A, or it's equal to just this element in A. So this element in A is equal to whatever the element in B is. You want to say how many possible array B's exist, or how many possible array A's exist. Excuse me. Under mod, because it can be huge. If all of the elements in B are positive, then it can be 2 to the n, I think. 2 to the n minus 1. So yeah, that's the idea. So what you want to notice here is the only thing that actually matters, like if you're looking at some prefix, the only thing that matters for the next one is what the sum of those values are. What those values actually are isn't important. All that matters is the sum. So if we store how many ways are there for us to get each different sum, we can use that information to calculate what we care about for the next step, which is how many ways are there for us to get each sum, and also how many ways are there total, I guess. So basically, all we're interested in here, which should kind of jump out from you after reading the problem and thinking about it for a bit, is we need to keep track of how many ways are there for us to get each prefix sum for each prefix of the array, for each prefix of like from 1 to n. So we have 2 different choices, I guess, for each step. One choice is this element that we're looking at right now is just part of A. If that's the case, all of our prefix sums will change by bi. Right? If this element here is just equal to A sub I, then after this step, all of our prefix sums will change by the same amount. The other option, which is the only other choice, is this element here is exactly equal to whatever the prefix sums are. So we have 2 choices for each step. Either all of our prefix sums change by the same amount, right? The number of ways to have a prefix sum of 5, if we add a 4, is the same as the number of ways to get a prefix sum of 1. Because it was a prefix sum of 1, then we added a 4, now it's a 5, right? So either we need to change the number of ways to get each prefix sum, right? The number of ways to get a prefix sum of x needs to now be the number of ways to get a prefix sum of x plus b sub I. So that's one option. The other option is we can just have our prefix sum be this value. Our prefix sum is now bi. So we need 2 operations. We need shift the array by a certain amount. We also need set this index to some value. And you can do that with a hash map, obviously. So the idea with a hash map is you can do, you can store some delta. So you can say everything in this hash map is really offset by some delta amount. And then if you change the delta, that shifts everything in the hash map by a certain amount. You just have to make sure when you put something into the hash map, you unshift it by the delta, so that when you shift it by the delta to go look, it's in the right spot. So yeah, that's just what this looks like. I think I did a good job explaining that. But if you have any questions, feel free to let me know, either in the comments or somewhere else. I guess you can message me, or I guess maybe don't message me, because then if I get a bunch of questions, they're all the same. Yeah, but you can ask on the editorial page or ping me on the contest announcement. I'll be happy to answer there. Awesome. Well, that's all for round 701. I hope you enjoyed. Let's see how I finally ended up doing. 16th place, not bad. Power of 2, also a number mentioned in the problem. In problem D, number 16. A of I all went up to 16, so kind of an important number. Yeah, so I enjoyed it. Anyway, I hope you enjoyed the contest as well, and hope your rating went up if it was rated for you, if you're Div 2. Otherwise, hope you just enjoyed the problems like I did. Hope you have a great day. That's all from me. Goodbye.